Okay. Good afternoon, everyone. Oh wait, I see I might have missed a chat. Just a moment. Yep. Good afternoon. Okay. Before we get started, just wanted to talk about something quick. A few things. So actually, on Friday's class, I just tried something new, which is and gave like a quick survey at the end. Well, it's optional. Okay. So and then I'd said that I would kind of go through the results today. And so that's what I want to do first. Okay, so this form had like 5 questions. Okay. Let's see. And I'm going to read some of the answers to the questions. I think at least for a few weeks, I want to keep on doing it. If it keeps on being useful, then I'll continue, I think just so you know, like 3 people answered, and even though it's so few people who answered, I think I still found it pretty useful, so I'll keep on doing it. So I just wanted to read a few of the answers. So the form had about, the first question asked when you were most engaged. Okay, someone said the first little bit of Friday's class. Someone said they are only catching up, so they weren't engaged. They're catching up with their classes. And then someone else said direct products was useful. And this means that I should try, first of all, if you're not caught up, I definitely understand that. So, we're just trying our best. Okay. And when someone mentions direct products, maybe it means I need to think about maybe something about how I taught that was good, and maybe the other things I taught weren't, but that's okay. And then the second question was when you felt most distanced. Someone said Monday because there's an assignment due. That's totally fair. I guess that's why it's nice to have recordings. If you can't watch it today, you can just watch it tomorrow. Okay. Someone said they weren't in class. Again, that's why we have the recordings available. Then someone else said they were most distanced when learning about composition series. That tells me I need to maybe spend some more time on composition series, at least with a video. So that is what I plan to do. Okay. Let's see. And then this is a really helpful comment I saw. So the third question was, what is something that someone did that was helpful? Okay. And then one of the answers said that the person who asked if CMN is isomorphic to CM cross CN, they said that was a helpful question. Okay. So I think that kind of tells me that the questions that people ask can help in ways we don't realize. Okay, so I thought that was useful for me to know. Okay. And then okay. And then someone just put like a comment that I said something that helped the person understand something done a few weeks ago. That's good to know. Okay. I'll just try and keep on going. Okay. The fourth question was, what is something that happened that was puzzling? Okay. Someone says everything seems to be confusing in the beginning because of, well, basically because of the pandemic. Yeah, I agree. This pandemic thing is not for me. Okay, and then the fifth question, what surprised you most? Someone said the exam was surprising. Okay, maybe it means I should give you more warning about the exam. I hope it wasn't so surprising, but oh well. Okay. Okay, so yeah, I guess if anyone has anything they want to add, they can, right? I mean, if anyone wants to add their comments, but if not, that's okay. I'll do this again in Friday's class. And then this will hopefully be useful. Wait, I think my video switched. Just a moment. I guess I should just do that. Okay, that seems to be good now. Okay, so that was just a quick, well, it wasn't that quick, but just a summary of some of the answers to this little quiz. This was useful for me, and I hope it was maybe helpful for you too. Okay. Other things, let's see. So kind of mentioned this. I have some things I owe you. I owe you an assignment 5. I'll title this I owe you. Okay. This is not really focused. There we go. Okay, I owe you assignment 5. I at least want to do another video about composition series with examples, something so that it makes more sense. See, I also owe you marking. Okay. And I also owe you like solutions for, I think, exam 1. Okay. Okay, so that is what I will be working on for you guys in the near future. But in class today, I wanted to just continue on and talk about solvable groups. Okay. And this is a related topic to, this is kind of related to composition series. So I hope that this can kind of tie in and kind of make things make more sense. Okay. So yeah, that is what we want to talk about today. Solvable groups. Okay. Okay. Before we talk about solvable groups, I just wanted to like circle back and just touch on isomorphism theorems. It's because they come up now and again. And I don't want to I want to make sure that when we apply an isomorphism theorem, it's making sense. Okay, so first, either review, or if you don't remember, this is just the first time you're seeing it, and that's okay too. So let's review the isomorphism theorems. Okay. The first one says that okay, if we have a homomorphism from G to H, okay, then this gives us an isomorphism of two groups related to G and H. And there is an isomorphism phi bar from G mod the kernel of phi to the image of phi, called phi of G, such that, and the definition of the isomorphism is that I have to tell you what, if I have a coset of G mod kernel of phi, I have to give you something in phi of G. So a coset of kernel of phi is x times kernel of phi. And the definition of phi bar just says do phi of x. Okay. So what it tells us is that if you have a group homomorphism, you get an isomorphism of groups between G mod the kernel of phi and the image of phi. And this can help you, this can help you make sense of a lot of things. For just as a quick corollary to this is the first isomorphism theorem. Just as a quick corollary, let G be a simple group. Okay. And let phi from G to H be a homomorphism. Then either phi is injective or phi of G equals the identity of H for all G. Okay, that's just a corollary from the first isomorphism theorem. Okay, let me get a new piece of paper. So let's try and prove it. Proof. Well, I mean, this isn't really a corollary to the first isomorphism theorem, but let's still prove it, as it is related. Okay, so we have to show either phi is injective or phi is essentially trivial. Okay, so first of all, if I have a homomorphism, the kernel of phi is normal in G, right? This is something we can see, like say phi of G is the identity of H. This equation describes when G is in the kernel of phi. Okay, now look at phi of x G x inverse. Well, phi is a homomorphism, so we can split it up like phi of x, phi of G, phi of x inverse. That's because phi is a homomorphism and it respects the multiplication. Okay, phi of G is the identity of H. So we have phi of x, EH, phi of x inverse. EH is just EH times this is just this. We get phi of x, phi of x inverse. And now phi of x times phi of x inverse is phi of x inverse. That's phi of the identity of G. X times x inverse is the identity, and that's the identity of H. So this tells us if phi of G equals the identity, then phi of a conjugate of G is the identity. This tells us that if I look at the kernel of phi and conjugate it, I still remain in the kernel of phi. In other words, kernel of phi is a normal subgroup of G. Okay, now G is a simple group. That means its only normal subgroups are either the trivial subgroup or the whole thing. So G is simple. That tells us that kernel of phi is normal. So either the kernel of phi is the trivial subgroup or all of G. And if kernel of phi is trivial, that means that phi is 1-to-1. And if kernel of phi equals G, that means that phi of G equals the identity for all G. Okay. Okay. So that tells you if you have a homomorphism from a simple group, it's either what you would call, it's either 1-to-1, which you might call it an embedding, or it's completely trivial. Okay. Okay, that's just a quick something. Okay. So what it tells us is that there's a relationship between homomorphisms and normal subgroups. That's the first isomorphism theorem. The second one, I guess I'll just skip, but this is important too, but I really wanted to talk about another isomorphism theorem. Okay. This is like the lattice isomorphism theorem. Which has come up several times. Okay. So, and it says let G be a group, and let K be a normal subgroup of G, and there is a correspondence between subgroups H bar contained in G mod K and subgroups containing K and that are contained in G. And this correspondence is given by let's see, let me write on a new page. Okay, if I start with a subgroup of G mod K, I construct a new group which contains K by looking at the H's in G such that HK is in H bar. Okay, and if I start with a subgroup of G which contains K, I get a subgroup of G mod K by just looking at H mod K. Okay, and this correspondence is 1-to-1 and onto, and like these two arrows are inverse to each other and all that nice stuff. And not only that, but H bar is normal in G bar if and only if H is normal in G. Okay. Okay, and I wanted to single that one out because we've seen it a few times. And then let me just quickly remind you of the second and third isomorphism theorems. The second isomorphism theorem tells you that you can look at HK mod H. Okay, and you can look at let's see, K mod H intersect K. And these are actually isomorphic. Well, as long as H is normal in HK. So like a sufficient condition for this isomorphism to hold would be like, as long as H is normal in G. Okay, so if H is normal in G, you can form the product of H times K and mod out by H, and that's isomorphic to what you get if you start with K and mod out by H intersect K. And that's the second isomorphism theorem. Implicitly also, if H is normal in G, then H intersect K is normal in K. Okay, that's just a very brief version of the second isomorphism theorem. And how I like to remember it is it kind of almost lets you cancel H's. So if you have HK mod H, you can cancel the H. Well, almost. You have this like kind of thing left over. And then the third isomorphism theorem it is a similar kind of cancellation. You have G mod K mod H mod K, and that is isomorphic to G mod H. You can cancel off K's as long as K is normal in G and H is normal in G. Oh, yes, and K is contained in H, which is contained in G, and that's the third isomorphism theorem. Okay. Okay, and that's the isomorphism theorems. Just a quick treatment. Okay, and it kind of lets you do the things like quick calculations, like whenever you kind of would naturally want to cancel these denominators, and the third isomorphism theorem says that's okay. You want to cancel something on the numerator and denominator, and you can almost do it, except for you have this like bottom term. Okay, so just these isomorphism theorems just let us do convenient calculations with quotients and things like that. Okay. The reason I wanted to go over them in this class is because these kind of calculations come up not only for composition series, but also for solvable groups. Okay, so I wanted it to be more fresh for when we tackled these topics. Let us now take this 5-minute break. And then when we come back, it's time to introduce solvable groups. Probably we'll have to continue on Friday. Okay. So yeah, see you guys in about 5 minutes.